In this video, we will discuss data types. A variable in Java must be a specified data type. Example, int mynum equals to 5. This example has data type of integer, which is a whole number. Float myFloatNum equals 5.99f. This is a floating point number. Char myLetter equals d. This example has a data type of a character. Boolean myBool equals to true. This example variable has a data type of Boolean. String myText equals hello. This is a string data type. Data types are divided into two groups. Primitive data types, those include byte, short, int, long, float, double, boolean, and char. Non-primitive data types, such as string, arrays, and classes. You will learn more about this in a later chapter. Primitive data types. A primitive data type specifies the size and type of variable values, and it has no additional methods. There are 8 primitive data types in Java. These are the byte, short, int, long, float, double, boolean, and char. Byte has 1 byte, and it stores whole numbers from -128 to +127. Short has 2 bytes. It stores whole numbers from -32,768 to +32,767. Int has 4 bytes. It stores whole numbers from -2,147,483,648 to 2,147,483,647. Long has 8 bytes and it stores whole numbers from -9 quintillion, 223 quadrillion, 372 trillion, 36 billion, 854,775,808 to 9 quintillion, 223 quadrillion, 372 trillion, 36 billion 854 million 775,807. Float has 4 bytes and it stores fractional numbers, sufficient for storing 6 to 7 decimal digits. Double has 8 bytes. It stores fractional numbers, sufficient for storing 15 decimal digits. Boolean has 1 bit. It stores true or false values. Char has 2 bytes. It stores a single character or letter or ASCII values. Numbers. Primitive number types are divided into 2 groups. Integer types stores whole numbers, positive or negative, such as 123 or -456. Without decimals. Valid types are byte, short, int, and long. Which type you should use depends on the numeric value. Floating point types represents numbers with a fractional part, containing 1 or more decimals. There are 2 types, float and double. Even though there are many numeric types in Java, the most used for numbers are int, for whole numbers, and double for floating point numbers. However, we will describe them all as you continue to read. Integer types. Byte. The byte data type can store whole numbers from -128 to 127. This can be used instead of int or other integer types to save memory when you are certain that the value will be within -128 and +127. Example, byte mynum equals 100. Take note, 100 is within the range negative 128 and positive 127. So it can be stored as byte. System that outprint ln mynum. Short. The short data type can store whole numbers from negative 32,768 to positive 32,767. Example, short mynum equals 5,000. System that outprint ln mynum. Int. The int data type can store whole numbers from negative 2,147,483,648 to positive 2,147,483,647. In general and in our examples, the int data type is the preferred data type when we create variables with a numeric value. Example, int mynum equals 100,000. System that outprint ln mynum. Long. The long data type can store whole numbers from negative 9,223,372,854,775,808 to positive 9,223,372,854,775,807. This is used when int is not large enough to store the value. Note that you should end the value with an L. Example, long, mynum equals 15 billion L. System that print ln mynum. Floating point types. You should use a floating point type whenever you need a number with a decimal, such as 9.99 or 3.14515. Float. The float data type can store fractional numbers from 3.4e negative 0.38 to 3.4e positive 0.38. Note that you should end the value with an F. Example, float mynum equals 5.75f. Take note that the value 5.75 is a number with the decimal 0.75. So that's why we have to declare it as float. Then we have a print ln mynum. Next we have double. The double data type can store fractional numbers from 1.7e negative 308 to 1.7e positive 308. Note that you should end the value with a D. Example, double mynum equals 19.99D. System that outprint ln mynum. Booleans. A Boolean data type is declared with the Boolean keyword and can only take the values true or false. Example, Boolean is Java fun equals true. Boolean is fish tasty equals false. System that outprint ln is Java fun. This statement will output true. Next, print is fish tasty. This will output false. Boolean values are mostly used for conditional testing, which you will learn more about in our later discussions. Scientific numbers. A floating point number can also be a scientific number with an E to indicate the power of 10. Example, float F1 equals 35E3 F. Double D1 equals 12E4D. System that outprint ln F1. System that outprint ln G1. Characters. The char data type is used to store a single character. The character must be surrounded by single quotes like the letter A or the letter C. Example, char my grade equals the letter B. System.out println my grade. Alternatively, you can use ASCII values to display certain characters. Example, char A equals 65, B equals 66, C equals 67. System.out.println A. System.out.println B. System.out.println C. Strings. The string data type is used to store a sequence of characters or text. String values must be surrounded by double quotes. Example, string greeting equals hello world within the double quotes. System.out.println greeting. Non-primitive data types. Non-primitive data types are called reference types because they refer to objects. The main difference between primitive and non-primitive data types are primitive types are predefined, already defined in Java. Non-primitive types are created by the programmer and is not defined by Java, except for string. Non-primitive types can be used to call methods to perform certain operations, while primitive types cannot. A primitive type has always a value, while non-primitive types can be null. A primitive type starts with a lowercase letter, while non-primitive types starts with an uppercase letter. The size of a primitive type depends on the data type, while non-primitive types have all the same size. Examples of non-primitive types are strings, arrays, classes, interface, etc.